Hi, welcome back to Math 112. We're going to talk today about section 7.2. And section 7.2 introduces some new identities. And remember, these are just relationships between different trigonometric expressions. And these identities specifically address trigonometric functions that are applied to the sums and differences of two angles. So let's start by taking a look at the identities, and then I'll explain to you where these come from. So these are the identities we're going to be dealing with in this section. What these do is they let us look at something like the cosine of one angle minus another angle. Now you might be thinking, well, can't I just do the subtraction and plug it into my calculator? And the answer for the most part is yes. Unless you're either facing a question that says, give me the exact cosine of something. So for example, find the exact value of the cosine of 75 degrees. And we'll work this example in a minute. And that's one instance where you'd use the angle sum identity. And like I said, we'll talk about how we're going to do that in a second. The other example where you might have to use an angle sum or an angle difference identity would be if you were asked to on the way to solving an equation, you would be asked to rewrite the sine of x minus pi over 4 in terms of sine x and cosine x. So let's go ahead and take a look at these. Well, let's go ahead and talk about where these identities come from. So where do these weird expressions come from? Well, they don't come from thin air and they don't come from magic. They actually come from geometry. So let's go out to Desmos, because Desmos makes this very easy to visualize, I hope. All right, so what I've got here is just the unit circle. Now I'm going to put a point on my unit circle at an alpha angle of rotation, and it really doesn't matter where that alpha is. I'm just going to put it right there. Now, and I labeled this point C, just for no good reason. Let's talk about another point P that is at the angle beta. Okay? Now remember, I'm trying to develop an angle sum identity, so I want to think about the point Q that would be at the angle alpha plus beta. All right, and here comes the geometry. So it turns out that if I think about the length of the line that connects P and Q, that line that I just put on there is the same length as the length of the line that would connect my original point C to the point 10 on the x-axis. So what that really means is the distance between P and Q is equal to the distance from my original point C to the point 10. And let me prove to you that those are indeed the same distance. And what I'm going to do is I'm just going to rotate my PQ triangle up to my CD. And you can see that yes, they are indeed the same distance. And here's the thing, it does not matter what alpha is. It does not matter what beta is. Those two lines are still always the same length. In other words, the point PQ is always the same distance, or those 2 points are always the same distance apart as the point C D, and D is at the point 1, 0. So what we would do is we would write the distance formula because we know the coordinates of those points, right? Let's remind ourselves that we know some stuff here. Yeah, that'll work. So let's remind ourselves of what we know. I'll do this on a separate sheet. Come on. Okay, so remember that we know the coordinates of these points, right? We know that this guy, this point P, is at the coordinates cosine beta, sine beta. And this point C is at the coordinates cosine alpha, sine alpha. And so Q would be at cosine alpha plus beta, sine alpha plus beta. And this is of course the point 1, 0. So we can write the distance formula. So just to show you how this works, the distance, the length of line QP, is the square root of the difference in x coordinates squared plus the difference in y coordinates. Right? And we can write the distance from point C to point D. That's the square root of the difference in x coordinates plus the difference in y coordinates. And the fact that those two distances are equal means we can set up this equation. The square root of the cosine of alpha plus beta minus the cosine of beta squared plus the sine of alpha plus beta minus the sine of beta squared is equal to the square root of the cosine of alpha minus 1 squared plus sine squared alpha. Okay, we can do work here. We can square both sides, get rid of those square roots. We can expand those quadratic binomials, and we can eventually get to the angle sum identities and we could get to the ones for both sine and cosine. What I'm going to tell you is I understand that it's very tedious to watch somebody do this in a video unless you are really, really a math geek. And I'm going to not put you through that because I suspect that most of us are not really, really math geeks. I am, and I would actually find this kind of enjoyable, but I'm not going to force that on you. The derivation for one of these identities is in your textbook, and if you are curious about the others, you can always look them up on YouTube. So that's where these identities come from. These identities come from this relationship between these two distances and the fact that they are always indeed equal. I'm going to come back in the next video and I'm going to show you how we use these identities to carry out these examples that I've put up on this screen.